All right, well, it's perhaps the first beautiful day in a while in our stay-at-home order in Wisconsin, so I figure it's time to do a little science video. So over here I have one of these infrared thermometer guns, so I can point it at things and it tells me the temperature. So, for example, if I point it down at the ground over here, or I guess at the floor of my balcony, it's about 58 degrees Fahrenheit, which is actually remarkably close to the actual temperature. It's about 59 degrees Fahrenheit right now. The way that this guy works is the laser is used for pointing. The laser does not actually measure anything. And the way that this thing measures temperature is there's a little infrared detector inside this gun, down all the way at the end of this big hole over there. And what it's doing is it's measuring long-wave infrared radiation between about 8 and 14 microns. I don't know if it says on this guy what exactly the wavelength range is. It doesn't, but it's about 8 to 14 microns. And it essentially uses that and infers what the temperature is. Essentially, it converts the thermal radiation coming off of the object and back calculates from that what its temperature should be. So we can point it at different things that are far away. So for example, let's point it at the ground. Point it at the ground and take a look, see what it reads. It's about 58 degrees. That's the temperature. You point it at the ground somewhere else. 58 degrees, that's what the temperature is. Now if you point it at the sky, we're going to point at the sky kind of in that direction over there, maybe aiming at those clouds, and we take a look. It's about 35 degrees Fahrenheit. We go up a little higher, maybe at a diagonal. Sorry that you can't quite see what it says. So it's 13 degrees Fahrenheit. If you look up, almost straight up, it's about 7 degrees Fahrenheit. And if you go all the way as straight up as possible without me dropping my phone, it's about also 3 degrees Fahrenheit. And I can repeat this process kind of in any direction and get the same thing. So for example, if I point at the diagonal over here, I get about 14 degrees Fahrenheit. And if I point kind of up there at the moon, roughly, of course I'm going to miss the moon, it's about 3 degrees Fahrenheit. So pretty much no matter what, if the actual temperature of most objects that I point to is about 58, 59 degrees, and I point at the sky, it goes from being about 30 degrees Fahrenheit all the way up to about 3 if I point straight up. So the question is, what's going on? Well, what's going on is this thing measures the temperature of whatever it's pointing at, roughly. So if I'm pointing at the ground over there, it's looking at the thermal radiation that's coming off of the ground and inferring from that that the ground is at, right now, 57 degrees Fahrenheit. However, if I point over there, well, there's kind of nothing in my line of sight other than the sky. So I get some moisture that's suspended in the air, maybe eventually reaching some of those clouds and so forth. And they're colder than 58, 59 degrees. You know that as you go up, things get colder. However, when the reason why the temperature changes from about 30 degrees over there to about 3 degrees Fahrenheit up there is not because the sky is, for some reason, colder straight up, or rather let's say the clouds are colder straight up than they are if I look kind of at the horizon. The reason is because the atmosphere is effectively thinner, or the path through the atmosphere is shorter if you go straight up versus if you go kind of in that direction, right? So the atmosphere has some sort of thickness. I don't know what it is. It's many, many, many kilometers. But if you look kind of in that direction, along the direction of the Earth, you're going through much more atmosphere than if you're going straight up. That's, of course, the shortest path through the atmosphere, and eventually we get up into space. And the reason why the temperature when you look up is about 3 Fahrenheit and over here about 30 is because we have a more direct path into space, and space is very, very cold. Actually, the temperature of space is about 4 degrees Kelvin, which I cannot do the conversion to Fahrenheit in my head, but it's probably something like minus 480 degrees Fahrenheit or something like that. So if you had the most clear sky you could possibly imagine, no humidity, nothing in your atmosphere, and you point straight up, you should go way, way, way off scale on this infrared thermometer, and maybe I'll try that on a clear day. But today we're getting some of the temperature of the atmosphere mixed with some temperature of space, and today that combination means about 2 to 3 degrees Fahrenheit.